Welcome to the third webinar in our second webinar series, Reimagining Supply Chains in the Digital Economy. Thank you for joining us today. I would like to thank our sponsor, the Port of Newcastle, and also thank our supporters, Macquarie Business School, Center for Workforce Futures, and Michigan State University's Broad College of Business. I'd like to begin with a quick technical overview. If you'd like to ask a question of our panelists, please send it via the Zoom Q&A button. We welcome your questions and observations, and we'll try and answer as many of them as we can. If you're having any technical issues, Carlos Abeja from our IT team is here. So either email him or send him a message on the Zoom Q&A button. Thank you, Carlos. My name is Norma Harrison, and I'm a professor of management at Macquarie Business School and Macquarie University. I'm going to serve as the moderator for our session here today. We've got a great team here providing support for this webinar. I'm assisted by Razia Tavaloy and Elena G. Liangjie, both from Macquarie Business School. The third webinar in the series is called Restoration and Reconfiguration through Digital and Analytics. In this webinar, we've had quite a bit of interest from over 150 registrations, and we have a group of presenters who are all experts in digitalization and data analytics, AI, in one way or another. So we have Nejhdeh Ghevondian, who is a principal data scientist at Microsoft. And we have Lambros Photios, CEO at Station 5. And then Xiande Zhao is a professor of operations and supply chain management at China Europe International Business School. Nejhdeh Ghevondian is our first speaker. He's the principal data scientist at Microsoft, where he leads a team of data scientists, software developers, and analysts. Nejhdeh has had more than 20 years of client-facing experience, delivering complete enterprise-level data analytic solutions across financial, gaming, retail, and healthcare throughout the analytics development lifecycle. Nejhdeh previously worked in similar positions at Hewlett-Packard, Ernst & Young, and AIMedics. He has also achieved granted patents, design awards, and publications within the field of data algorithms and engineering principles. Nejhdeh earned a Bachelor of Engineering in Electrical Engineering and a Master of Engineering Computer Science, and a PhD in Computer Science, Software Engineering, Machine Learning from the University of Technology, Sydney. So I present to you Nejhdeh Ghevondian.
Thanks, Norma, for that introduction. So today I'll just talk very briefly about how AI and underlying the AI machine learning can help organizations and companies, particularly in supply chain, but not only in supply chain, in other cross domains, use the power of AI to either improve business, improve the business outcomes or efficiency. So that's the main core topics for today. Just to recap very quickly, I know this is probably been seen by some of the people in the audience, but it's just talking about the digital feedback loop, where it's accompanying three aspects: the data, which is fundamental, I guess, in terms of AI and machine learning, the intelligence that can be drawn out of the data, and the ultimate action that can be performed based on the data and the intelligence. So these are the kind of the three pillars that form the digital feedback loop. And across the feedback loop is also includes the four typical, I guess if you can call it the use cases can be drawn from it, including engaging customers. It could be optimizing operations, which is very, very valid to the supply chain industry, transform products, and empower employees in terms of the people taking actions from the AI to able to advance the organization. So we'll go next. So again, just a recap, typically what organizations been doing, they have a strategy and then they drive from the influence, they drive through the data and perform some action, right? Let it be supply chain, let it be manufacturing, let it be other industries. What we see in the industry, at least from Microsoft perspective and working with clients, we see that now the data is driving the strategy. So that's kind of the hybrid version of now let the data show what's possible through the actionable insights and the business improvement processes. So that's having said that in terms of the slides, and is saying, what is AI? Well, of course, a lot of people here probably heard of AI or some level of AI. Some people have learned about ML and deep learning and so forth. Really, what we like to put into a pillar is this sense, comprehend, and action. So again, sensing in terms of could be computer vision or audio processing. Comprehend is where you take the sense and you comprehend some sort of a knowledge output or knowledge transfer, right? Natural language processing is one aspect, knowledge representation, and then the action, which is you perform the machine learning and the expert systems that come out of the AI actions, if you like. So that's kind of puts it into a pillar perspective and the emerging AI technologies. So how do we adopt AI in trends in manufacturing supply chain? So again, these are, I'm going to give examples of what we do in the field, what we do with clients in the industry, particularly in the APAC region, so the Pacific and the Asian Pacific region. So next, Norma. So again, I won't spend too much time on this slide. It might be a bit busy, but at least it shows typically a journey map that we envisage through our clients. So starting from inbound logistics to optimizing transportation and so forth. So if you go through the whole journey map, if you like, you can see all the touch points where AI can help improve or at least make it more efficient, right? Right up to the point of output logistics and out to the business and so on. So hotspots in terms of adaptation from a digital and AI perspective. And again, I'm sure there's a lot of subject matter expertise in the audience, but just to highlight why AI can help is, for example, just looking at a couple of areas, which we'll talk about a bit later in the talk, is optimizing transport and routing. That's very typical on where AI can help more advanced machine learning, right? Supply chain performance, understanding how the performance can be improved, or what is the leakage, or what are the anomalies and so forth, right up to remote monitoring and controlling. So allowing the execution of the manufacturing processes and then monitor for efficiencies or deficiencies, really. So again, this is kind of the map. Please take time to read, but these are the typical things that AI can help with the adaptation. Next, Norma. Okay. We may or may not spend too much time on this. Sorry for going through it quickly, but what is an intelligence system? Again, it's really another packaged way of saying AI. Now, I've had another slide, but it was going to be a bit too much. Just to demystify what's AI, what's ML, what's deep learning, but just in a nutshell, intelligence systems where you package everything you do from an advanced analytics into a system where it could do something for you, an action, a prescriptive action, right? And again, some terminologies you might have heard, predicting an outcome, that's quite obvious. Predicting what my warehouse utilization will be, or predicting how many trucks will arrive given at this time of day. That's pretty obvious. But these are kind of an intelligence systems that can be packaged. Recommendation systems is what you recommend is the next best action. Again, we talked about outliers and grouping. Cognitive capabilities is these packaged if you like, software. I wouldn't call it products, but solution offerings where it can help with the supply chain logistics businesses vision. For example, you can have a camera that could detect in real time what your pallets look like or the level of utilization in the warehouse, and it can give you a real time, obviously through AI and digital implementation. Okay, your warehouse is 60% utilized, or the rate of decrease of your certain product is, or stored product is so and so. So again, these are the kind of a visual perspective, or even safety of your the truck driver, safety of your warehouse employees working at the particular warehouse to give you a detection of predicting if it's going to be safe or not safe, or give it a scoring. Next, Norma. Again, we touched upon a few of these. I won't go too much detail, but again, these are another 6 examples of typical where AI can help. Not just, as I said, not just in logistics, but general business operation. Lowering operational costs is a good example. Risk reduction, we talked about, this is customer risk profiling. You can do employee safety risk profiling, and so on and so on. So please take time to read and how that adopt. Now, this was a good kind of a deck to put together because it talks about the connected supply chain. We call it the digital twin, where you take a process, it could be your supply chain footprint, and digitize it as in put into a platform or a system where you can actually start doing the digital implementation and the AI on top of that. What's the benefit of all this? And again, obviously we've kind of highlighted that, and for some subject matter expertise on this call is quite obvious, but this is good where it shows how you can extract different sources, your CRM process, the ERP and so forth, and put together a digital tool where you can start driving outcomes out of the AI. So this is what we call it a connected, some people call it connected factory in a manufacturing, we call it connected supply chain visibility in the supply chain industry. So yeah, that's kind of a backdrop. What I want to get into.
I have a question for you, Nej. This data platform seems to be an ecosystem wherein all the partners of the supply chain are interacting seamlessly and with transparency to achieve the aims of the supply chain. Do you see this happening in the majority of your customers' projects?
Good question. And look, I like to say yes, but the reality is no. So when I say no is when we embark on working with clients on the projects, we see that there's very disparate sources, right? Although companies and organizations like to say we're unified in a data platform, which is the ideal process to be. The reality is, yes, they do have platforms, right? They could even have multi-cloud platforms, and that's fine. There's nothing wrong with it, can coexist, but there's not a seamless unification. And maybe there will never be exactly a pure unification, but there isn't that total seamless. Example, we see this in a banking a lot, where the credit card retail group has no interactions with the home loans group, even though as a banking organization, you want to get a cross correlation of all the data that you can then draw insights from a top level business perspective. So short answer is no, but companies are working towards towards getting that level. And again, that's very key, important point you brought up, Norma. Okay, some examples, and we're running out of time, so just very quick examples. We do this obviously as part of our delivery. I'm part of the Microsoft's delivery, data science delivery team. And again, we don't just do supply chain logistics, we do other activities and other projects, but 80% of it is the same. So across any industry, whether if it be manufacturing, medical, banking, retail, the type of AI and ML, machine learning that we do is cross-transferable. For example, this is a good one I particularly put in, not because it's directly logistics, but at least it talks about how you could perform demand forecasting and do a simulation modeling. Why is that important? Well, in your supply chain logistics, you want to forecast demand. How much demand would there be in 3, 6, 12 months time for a particular product or group of products? And then you can plan according to that, right? How much warehouse utilization there should be, how many trucks should leave at this time, and so forth, as you know, right? So this example, with the next slide, shows that by applying more deeper type science, data science related activities, you can get to that point. And again, you could roll this down into a typical forecasting or time series forecasting. I won't go too technical today, but at least it shows where this can be rolled up into a supply chain use case, right? So at the top, you see a typical graph where you could predict the spikes of demand, peak demand or peak troughs, right? And then able to plan accordingly 3 months beforehand. The graph at the bottom shows simulation modeling, certain what-if analysis. What if the demand increases by 10%? What should I do? By 20 or 30%? So you perform this, you simulate certain events, right? That it be, again, example is during the festive season or demands at a certain time of the year. How shall I provide some prescriptive action? And this is what simulation modeling in a high level perspective means. Okay, second one we talked about, Norma talked about, okay, how does it work with unifying platforms? And again, a typical thing, what we call industry is a data lake now. In the old days as in it's has a place for it, is the data warehouse, the traditional data warehouse where it's structured data. We now talk about a data lake where you have all sorts of data coming in. It could be your transactional data that comes in from how much supply you've got in your warehouse, to unstructured data such as emails from the supplier saying, we're going to delay shipment to your warehouse. And this is where your data lake comes in important. So an example here was where we did a project for a major APAC company where we can able to successfully implement a data lake. I know we're consciously running out of time, so next, Norma. This is a scheduling optimization, and I'm sure Professor Zhao was going to talk more on that, but just this talks about how, again, not everything is machine learning in AI. Some things are optimization problems where you can schedule things. And again, this could be scheduling your trucks leaving your port at a particular time to optimize cost or delivery time, right? So this is a real world problem where it's constraint-based. Again, I won't use too much technical terms, but in a nutshell, it's able to optimize some sort of a process in your organization. And you can draw analogies to that. Predictive maintenance is another big thing. You want to probably predict when for example, your trucks are going to fail. Again, I'm making this up, right? Or your forklifts are fail in a particular warehouse. So you can take mitigative action and fix this. Rather than scheduled maintenance, it's unscheduled maintenance. So that kind of a perspective. Again, another example we did in the APAC region where we helped to reduce cost, right? And keep uptime. So that was the main aim. Other than that, Norma, I think, and I don't know what's next, but I think that's it. So, yeah.
We'll see you again in the panel discussion. Thank you, Nejhdeh Ghevondian.
Thank you
for taking us through the description of AI, enabled innovation, the process of sensing, comprehending, and acting, and how a connected, unified data platform is necessary for supply chain visibility, and some great examples of AI adoption trends and projects in manufacturing and supply chain. So thank you for your good introduction in this field. I'd like to introduce to you now Lambros Photios, the CEO at Station 5, a software development company based in Sydney since July 2015. Since mid-2017, Lambros separated himself from just the business software development processes, and he established a management team and eventually became an advisor to a number of globally recognized consulting firms and financial institutions. Lambros has acted as a mentor, advisor, and keynote speaker to a number of tech-based organizations spanning blockchain and artificial intelligence. Lambros earned a Bachelor of Engineering and Bachelor of Commerce at the University of New South Wales, Sydney. So I present to you Lambros Photios.
Thanks, Norma. So that was a great chat by Nejhdeh there. But I think for the purpose of this, and given what Norma just alluded to, I think the biggest problem I've seen through my kind of consulting career over the past five and a half years has really been, I think that people try and focus too quickly on the state of the art technologies and don't necessarily have the structures in place to really support it. But let's just zoom out for a little bit and talk a bit about data analytics, just conceptually. So generally when we do data analytics, we're really trying to focus on two kind of main agenda items. The first is we want to review historical data. So we want to see kind of what happened historically in the past. And then what we try and do is we try and take either qualitative or quantitative data and use that to justify why what happened in the past actually happened. But let's push forward, Norma. Really though, data analytics should be broken down into 4 key steps. So We spoke briefly about 1 and 2, which you see here. So first is descriptive, which is explaining what happened historically. So what happened in the past. The second step is diagnostic, which is explain why it happened. And that's where that justification comes into play. And what we've started alluding to through Nejhdeh's talk and what we'll talk about a bit later are predictive and prescriptive stages as well. So we're going to kick off with 1 and 2, which are descriptive and diagnostic, which is, really what I think a lot of companies need to look back at and master first, and then look at predictive, which is really trying to work out kind of where things could potentially go wrong. Where things could potentially go, and then prescriptive, which is running simulations and trying to optimize. So where do companies go wrong? Let's just kind of rewind here for a second. What I've done is I've just pulled together a few kind of insights as to, I guess where companies are currently going wrong, because as I said, the reality is people aren't generally describing and diagnosing their data correctly. They're trying to think about state-of-the-art technologies like blockchain, artificial intelligence, machine learning, and advanced CGE models that, quite frankly, they're just not ready for yet because they don't have the right infrastructure in place to support it. A few statistics here I found to be incredibly valuable. Forrester's reported in 2017 that insight-driven organizations are growing 8 times faster than global GDP and are growing on average 30% year on year, which is absolutely huge. And to create that kind of disparity, naturally, these companies are not doing anything beyond describing and diagnosing their data. They are doing the basics, but they're doing the basics well. 70% of businesses don't integrate their data sources. They don't do API integrations. They don't get databases communicating with each other through either custom or API technologies. And finally, 40% of the insights delivered by customer intelligence teams are not actionable. Norma, next. So let's start at the top. Let's talk about descriptive. Firstly, as an organization, you need to understand what happened historically. With data analytics, there's generally a couple of things you need to kind of focus on here. The first is making sure that historical data is comprehensive, it's accurate, and it's alive, or as up to date as possible, and that it's effective, right? It needs to be user-focused, needs to use design thinking, it needs to be accessible. I'd like to talk a bit to a case study here, because I think these are just words on a page until we actually talk about kind of companies that have put this into practice. We at Station 5 worked with one of the big 4 Australian banks during the Financial Services Royal Commission, which was effectively where there was a Royal Commission placed into all organisations Australia-wide around anti-fraud and making sure that they were doing things in the best interests of customers and upholding the law. And it was through this that a lot of risk officers within organization were really put under the microscope. And so we worked with a series of chief risk officers within one of Australia's big 4 banks. Our agenda was to do actually what Nejhdeh was speaking about previously, which was, what if you do want to consider data from, say, credit and home loans and compare those? The problem was that the risk team had no means of assessing data across those sources. So our job was to work with them over a period of 6 months, where we amalgamated 12 different departments' data sources into one. We then exposed that in a really high-level lens for the CRO. The CRO, Chief Risk Officer, ultimately needed that high level, but again, we need to think about the user focus. So if the CRO found something that was of concern, naturally she needed to alert her team as to what was happening, and then effectively flag that with the necessary department. Next, Norma. So next we need to go into kind of why it happened. It's all well and good to understand kind of what's happening, but then we need to justify the root cause of that issue. So this isn't just about visualizing data, but drilling into the root cause of why that event actually occurred. Again, we need to come back to the user who we're focused on. If we're focusing again with that kind of CRO issue within a large bank, do we have the right level of granularity for someone to understand what actually happened? Also, who is the person who's contributing to that data? So again, back to the banking example, if a CRO flags, hey, this doesn't look right, and raises it with, say, the home loans team, then does the home loans team only need to look at the data, or do they need to speak with the representative who is responsible for that action? So data can generally expose a particular issue, but a lot of the time we also need to communicate with people and understand what actually occurred at that point in time. It's important to think about isolation, but also cross-faculty, which is paradoxical in itself. So isolation is obviously focusing on a very specific vertical within the supply chain. It could be the last mile. But then at the same time, we need to think about cross-faculty data. So how is first mile impacting last mile? How is storage or manufacturing, impacting storage? How do these different faculties impact each other? We worked with a company down in Melbourne, a freight forwarder called Cora Group, for this piece, for a piece of this nature, I should say, where they had access to all of their data insights, but what they couldn't quite work out was what was having an impact on their DIFOT, their delivery in full on time. And so what we were doing was we were comparing across multiple different freight providers on their books, kind of what was contributing. We found there are a couple of suppliers who are consistently not delivering in full on time. And so you could have access to all the data, but if you don't know how to actually drill into that data and understand what the root cause is, that's where you can also have some issues. And this is why it's important to have experts or individuals who specialize in particular verticals of the supply chain, not just someone who looks at everything or an analyst who looks at everything at a high level and tries to make assessments as to what's happening. You need to create that relationship between the high level and the granular people. Next. So if you've got 1 and 2 correct, then the reality is you're already well ahead of most others in the industry. And to be honest, you can get very far. That statistic we spoke about, growing 40% faster than GDP, that is by covering off on 1 and 2 independently. Let's talk about point 3, which is being predictive. We generally talk about models. And we create these custom models, which, as Nejhdeh was alluding to, use things like machine learning or deep learning to forecast what might happen. The reality is, an interesting stat that I love because I work with a lot of the kind of bleeding edge startups, is that 40% of AI startups that are classed as AI startups have no actual AI tech. You kind of look at these sorts of statistics and you think, if AI companies aren't using AI, what's going on? As I said, the reality is getting the basis perfect, getting the structures perfect is what's really going to differentiate you. But then obviously it's important to take it to the next step. What is predictive? Predictive is looking at, based on a series of input variables, what sort of output can we expect? So it could be that you create a port model. Let's use the example of a port. And the port could be, say, New South Wales or Newcastle ports, where you have a series of vessels coming into the port daily. And it could be that there are certain variables and constants, and those variables and constants, naturally the variables are changing over time, but the constants remain obviously constant by definition throughout the process. What we need to identify, what predictive does, is it allows us to tweak those input variables to determine, based on historical data, so based on previous information, what will happen in the future based on the tinkering or the changing of those input variables. So it allows us as decision makers to say, okay, if we change this input variable and instead of 100 vessels coming in this month, we expect 120 vessels to come into the port this month, how will that impact the output? How many extra containers will we have on our hands? How many extra empty containers will we have on our hands? So this allows us to start really thinking about decision making. And then we go into prescriptive next. Prescriptive is the last step. Prescriptive is, I'll take that model example and kind of just take it to another level. Predictive, which we spoke about before, was, you can change that input variable from 100 to 120 vessels coming into a port per month. Prescriptive takes it to another level by actually looking at, okay, what is the business outcome that you're looking to achieve? What are you looking to optimize? And what it will do is it will create the maximum benefit by changing the input variables on your behalf. This is where machine learning really starts to come in. So it's not about, say, changing as a human 100 to 120 vessels and assessing what the outcome is. It could be that I've got a particular outcome I need to achieve, which is minimization of empty containers at the port, and it will communicate with me. It will optimize how many vessels achieve that optimal number of minimizing the number of empty containers at the port. So it's really just taking it to that other level where it's about actually achieving a human outcome. This is where, at the end of the day, as I say in the last point here, decision-making can either be streamlined or completely automated, because if the model or the algorithm is doing the work for you, and that technology is implemented correctly, then ultimately the decision makers the decision makers have this work being done on their behalf, and their role becomes an oversight.
Thank you, Lambros. I'd like to ask a quick question. In your experience as an advisor to companies wanting to delve into the world of data analytics and or predictive analytics, have you seen instances where companies have not been able to get to the predictive and prescriptive stages without problems? And what were the outcomes of these instances? And how would you advise them to get back on track?
Yeah, there was a client that we consulted to about 2 years ago, and they're in the ports area, and they were trying to achieve an optimization of empty containers, that exact problem I spoke about, and they tried to jump through to 3 and 4 immediately, and they hadn't actually covered off on 1 and 2. So what they tried to do was, in real time as the project was going, and we didn't cover the actual software development, we're kind of in an advisory capacity. They tried to do 1 and 2 against our advice as they were doing 3 and 4. And what ultimately happened was that a project that was estimated to take 3 to 4 months has now been going on for 15 months and is still not complete. The main premise for that is that when you try and do 3 and 4 without having the good structures in place, you can have the best software in place to do 1 and 2, but if you haven't set up the right culture within the organization that supports it, where people know what their responsibilities are, then it's ultimately not going to work. If you want to be a data-driven business, the culture needs to be aligned with that. It can ultimately drive a business forward, having that kind of mindset. But if that's not instilled upon the staff, we spoke before about high-level thinking versus low-level and being granular. If there's not a culture of that within the organization, you're setting yourself up for failure very, very early on.
Mm-hmm. Thank you, Lambros, Photios. You've illustrated that to effectively adopt data analytics, organizations have to be able to handle the basics of descriptive and diagnostic processes, and also to predict and prescribe. Your examples have been pretty good. I've been very interested in them, in illustrating the challenges of doing so. So thank you, and we'll see you soon in the panel. I'd like to introduce to you Xiande Zhao. Professor Xiande Zhao is Professor of Operations and Supply Chain Management at the China-Europe International Business School, or what we like to say CEIBS or CEIBS. And he's also Honorary President at the Association of Supply Chain and Operations Management, ASCOM. Xiande previously served for 12 years as professor in the Chinese University of Hong Kong, and this is where I first met him, and director of the Institute for Supply Chain Integration and Service Innovation at South China University of Technology. Xiande is a true Renaissance man and has conducted research in a wide variety of areas: supply chain management, quality, service, innovation, and now supply chain digitalization. He's a prolific writer with over 180 articles in good refereed journals. Xiande received his Bachelor of Science Chemical from Nankai University in China, and his Master of Science Chemical MBA and PhD from the University of Utah, USA. I present to you Xiande Zhao.
Thank you, Norma, for such a nice introduction. Welcome everybody to this webinar. I'd like to share with you the idea of regenerative supply chain. During COVID-19, we saw a lot of companies actually had many innovations in different parts of the supply chain, and we summarized some of the innovative practice with this new idea of regenerative supply chain. We also found this is a new and good model for post-pandemic conditions. So let's look what is really regenerative supply chain. Regenerative supply chain is a supply chain that reconfigures itself as conditions change or opportunity arises. The regenerative supply chain really has 3 key dimensions of capability. First, it can restart an old supply chain after it has completely stopped due to disruptions. So during COVID-19, especially in China, after the Chinese New Year, many supply chains had trouble with starting. And regenerative supply chain will be able to restart itself faster after the disruption. And then the second dimension is to reconfigure the supply chain by changing an old supply chain to produce new products. We saw a lot of good examples of that, and I'll show that to you later. And then the third dimension is to create a brand new supply chain to meet the new demands. Now, let's look at the case of Xiande. Xiande built Cosmoplate platform to help to link the different parts of the supply chain together. And during COVID-19, the company was able to quickly develop a medical material information and resources sharing platform. And through this platform, they were able to source medical supplies and equipment from all over the world to help the Chinese people and the government to deal with the crisis. Later on, they also used the platform to source material from China to meet the needs of demand in different parts of the world. They were also able to help Nejhdeh, a home construction company which used to focus on fabricated construction of unmanned convenience store, to produce medical isolation ward. The story was Xiande was a supplier for Nejhdeh during the regular time in producing the unmanned convenience store. And then when the CEO of this company saw the needs for having these medical isolation ward, he talked to a manager in Xiande, and then the Xiande manager put that on the Cosmoplate, and then they were able to get 62 people from multiple organizations to work together to quickly design and finish the design and then put that into production. The design phase is completed in 48 hours. And then they were able to get 3 construction companies to work together to do the volume production, and they were able to produce a product in 2 weeks. And then another example is Xiande used its Cosmoplate to assist a textile company in Shanxi province to switch production to the protective clothes and disposable masks. And then they also helped another manufacturer to switch production to intelligent temperature measurement and disinfection channel in 3 days. The question is, how can they do this quickly? How can they gather the resources and capabilities from multiple people, multiple organizations to be able to reconfigure new supply chains to meet the new demand? Let's look at this Cosmoplate platform. And we name that as a self-driving platform that enables supply chain restoration and also reconfiguration. Through the years, Xiande has accumulated the experience and the knowledge and built the systems for managing different parts of the supply chain. And in recent years, they link these resources and capability and also the systems into a whole supply chain management platform called Cosmoplate. In this system, there are 3 major modules. The first one is cooperative innovation and design module. Through this module, they were able to engage the final user, the upside designer, and the technology owner. They were able to interact with people in Xiande, and for different projects, they can gather the user, outside expert, and the internal people and do it quickly. After they come out with the design, then they have the production resource integration module, in which they gather the hardware module suppliers, hires, and other companies, the internet factory, and assembling capabilities. They also have the software developer and software module provider, and they combine the hardware and software to link the different productive resources from different companies to be able to produce the product they have designed. And then the third module is the delivery and the service management module. In that module, they were able to gather partners who are involved with the marketing channel, with doing the home delivery and services. And through this huge platform, they were able to integrate resources and processes from different organizations to form supply chain based on their practice needs. That's why we call this platform as a self-driving platform. Let's go to the next page.
Now, could I please ask you a question?
Yeah.
Zhao, I have always been intrigued by Hire's Cosmoplat, a living ecosystem of the supply chain, especially after visiting Hire in Qingdao, where you had this marvelous conference.
Yeah.
However, my memory of this platform was that of a very complex and sometimes confusing series of interactions between the various supply chain partners. How did you put all this logical structure we see in this slide into the platform now? And does it mean the same thing in terms of the myriad interactions of Cosmoplat?
Yeah. Actually, you asked a very good question. Hire has many different people involved with developing different parts of this platform. Each one of them has detailed descriptions of the parts that they develop. They are proud of it. But as professors, we have the advantage of being able to integrate knowledge. Actually, Professor Howley and also Professor Ferdo and I worked on this for several months, and we come out with this model and we show this to them, and they really feel this is really a very high level, precise conceptualization of what they did.
Mm-hmm. Great, good.
Yeah, so to make it simple, okay, this self-driving supply chain platform first provides the backbone for connectivity, transparency, collaboration, IP exchange, and also provide the testbed and experimental ground for new products, for channel development, and also for eventual sales. So most platforms do not really have such wide scope, and these wide scope allow all the participants to be managed by this platform. Secondly, it can help to reconfigure the supply chain quickly and efficiently as the condition changes or new opportunity arise. Thirdly, members in this platform can initiate projects based on market needs. They can find the right partner, collaborate with one another, and form trusting alliance in a self-driving manner. If you look at this platform, this is quite different from the control tower system that many companies have developed over the years. This platform helps to form the supply chain ecosystem where the partners can really form the supply chain together collaboratively. Hire does not necessarily have to be the leader for different projects. Yeah, that's really my high-level summary. And then in terms of how to use digital technology and big data to innovate in different parts of the supply chain, through my interactions with the different companies in China, we found the major area of innovation are in terms of demand forecasting. And one company who produce medical equipment, they use a platform where they have the X-ray film data shared, and they use the X-ray film result data to forecast the demand for medical equipment in different hospitals. And then global sourcing companies like Hire, through part of their platform, they were able to source material first from overseas to help people in China, and then later on, they also help other countries to source material from different parts of the world. And then the next one is flexible manufacturing. As you can see from my previous example, higher using the Cosmos Plate really helped a lot of companies to reconfigure the supply chain and produce new products. And then the next area is to use the data from different part of the system to match the supply and demand. And then the next one is to rationing the supply to meet the most important demand. And then lastly, digital technology and big data are also used to make warehousing and delivery decisions to effectively make the last mile delivery. So through all these innovations, Chinese companies are able to solve the problem of protecting the people and meeting their needs to protect themselves and also protect other people. At the same time, Chinese companies are really restarting their supply chain much faster than maybe companies in some other countries. One of the main reasons is first, they had the supply chain resources. They work on the supply chain collaboration and the relationship. At the same time, the advanced companies are using the digital technology and big data to help to link the different parts of the supply chain together. That's what I have planned to share with you.
Thank you, Zhao. That was very insightful. I'd like you to just stay on here because we are going to be talking about our takeaways. And so an invitation to all the panelists, please feel free to participate in this. So I just summarized it in some way. And so Zhao, digital technology, big data analytics, and supply chain collaborations. Do you find that all these need to be effective tools in coping with COVID-19?
Yeah, through my interactions with different companies, retailers, manufacturing companies, and also logistic companies, there is really a clear evidence that those companies which has a higher level of digitization, has a better use of big data analytics, and also focus on building the supply chain relationships, perform much more effectively than those companies which did not really pay attention to these things.
Yeah, thank you. And Lambros, Photios, you stated the basics in data analytics, the necessity to describe, diagnose, predict, and prescribe. Which one would you put as the most important factor?
I'd probably say diagnosing. I think a lot of companies are starting to get there with describing, but diagnosing at the moment is the most vital, particularly, looping from what was just said. I think COVID-19, large organizations are disadvantaged because of these huge data sets they've got, which they think are assets. They're disadvantaged because there's so much they need to go through, sometimes, 3-4 decades worth of data. If you can get people who are specialized in diagnosing your data and understanding what's valuable and what's not, I think that's putting you on the pathway to a much better position.
And I particularly liked in your presentation under prescriptive when you mentioned that decision-making can either be streamlined or completely automated if the right algorithms and technology are implemented.
Yeah, exactly. I think it's an oasis or like a perfect place to get to, but I think it takes a very long time to get there. And I think the organizational benefits can be realized very quickly with describing and diagnosing.
Thank you. Nejhdeh, Ghevondian, I see that you've got quite a bit of listings there and on what we can look at, and in particular, a connected unified data platform is necessary for supply chain visibility. So for quite a few different functions, huh?
Correct, yeah. So for enabling what was said by Lambros and Professor Zhao is, well, ideally you want to get to that unified platform, or at least attempt to unify some of the platforms, if you like, but at least try to have a more streamlined approach of understanding the different data sources to put together to do the diagnostics, prescriptive analytics, and so forth. And Professor Zhao's explanation of doing some of the more advanced optimization theory problems without having a proper viewpoint of your data. Well, it's going to be at most suboptimal in terms of your use case outputs.
Yeah, and then we get back to Zhao, supply chains with regenerative capabilities can emerge stronger post-disaster?
Yeah, actually, what we observe is this disaster really led companies rethink about what type of capabilities are needed in addition to reducing costs and improve quality and even make on-time delivery. We also found the supply chain has to be able to resist to the external disaster. In addition to that, due to the dynamically changing customer demands and needs, companies will have to be able to build regenerative capabilities so that they will be able to kind of reconfigure the supply chain from the existing supply chain or build new supply chains. They have to be able to do that faster. And I think in the post-COVID-19 era, companies will be able to pay more and more attention to these type of capability. And in order to really enhance these type of capabilities, they need the help of digital platforms, digital technology, and big data. And what we found in Haier is through these years, they build different platforms for different area of the supply chain. And when they can really link them together, that really help to build the regenerative supply chain capability. And when you are a good partner, you come into the system, you will be able to kind of self-drive your own supply chain with the help of this system.
Thank you. We've got quite a few good questions coming in now. So what I will do is I'll get to our panel discussion. And in this one, let me just start off with a question for Nejhdeh. And this is from Amrik Sohal from Monash University. Professor Sohal has asked, what is your experience amongst Australian businesses with respect to the adoption and issues and challenges they face with AI, etc.?
Okay, a very nice question, and it's, I guess it's difficult to answer that in a time frame that we have. Look,
sure.
If you could frame it in this maturity curve index, and again, MBA and business analysis is not my forte. I'm more of a bottom-up technical data scientist. But from what we see as a client-facing role, direct client-facing role, is majority of the organizations within Australia are kind of in the initial to mid stages of this maturity. I guess if you want to call it the data analytics maturity curve, right? And right at the top of the curve is the business metamorphosis, or the the likes of Netflix and Google and so forth, right? So a lot of companies are in kind of the initial phase, and there's nothing wrong with that. And Lambros did point out that you got to get the fundamentals right. If you can't describe your data, then everything else is flawed. In a gentle term, flawed, because you got to understand the data in the first place, right? So yes, majority. I can't put a percentage on it. I wouldn't say majority of it, but it's a good 30 to 40% of the company that's still in the very early stages of the maturity index. Some are really got about 10 to 20% are right at the kind of the business metamorphosis, but majority are still kind of lagging. Particularly, unfortunately, I think we find it in the financial sector, some parts of it. Manufacturing starting to make some leadways, but that's kind of at least the landscape we see. Retail actually is leading. Okay, retail in some aspects may not have the complexity of the supply chain logistics ecosystem issues, but they're leading from a digital perspective at least.
Yeah. The other panelists, do you want to react to this particular question? What's the experience with respect to adoption and issues? So probably maybe Lambros first, and then we can talk to Xiande.
So specifically adoption of this kind of culture change?
Yeah, and the issues and the challenges they face with AI, etc.
AI is an interesting one. AI is interesting, and I saw a lot of questions in the Q&A raised about this. I think you definitely need to start off with the fundamentals. I think in terms of the culture change, unfortunately, particularly with large organizations, it's very top down. The approach has to be top down. It needs to come from management. But when we worked, for instance, with one of Australia's big banks, ironically, we we found there was support from lower management who ended up building a business case with us to then present to upper management. And we framed it around the Banking Royal Commission. So it worked really, really well. So it needed, like the end decision needed to be driven by top management, by the C-level, but ultimately was, you know, kind of did start with lower management. They built a business case and it worked itself up 2 tiers before it got to the C-level execs. So it works to start with that kind of lower level management. In terms of AI, yeah, I mean, challenges are, I think that people a lot of the time, I think, and Nejhdeh, I might push this back to you, but I think a lot of people want to do AI because AI is cool and AI is funky and everyone's doing it. And there are great solutions out there. Microsoft has some great solutions I've personally used with Azure. So do Google and AWS. Microsoft's great for enterprise, really, really great for enterprise. Not that I'm selling Microsoft's products today.
Nothing wrong with that.
but you know, I think AI is great for enterprise when it makes sense. I think where people go wrong is they don't know what AI should actually be doing just yet. I think basic mathematical models with some advanced rule-based algorithms can get you very far before you then need to plug in a machine learning layer. And I think that those models, things like CG models, for instance, that don't have an AI layer, can go very far. So check out CG models as a potential mechanism for driving that sort of change and automated decision making that we spoke about.
Yeah, thank you. Could I adjust this question somewhat to Xiande Zhao, and adjusting it to say that, you know, we've labeled, that was one of your slides where I think it's your last one, where you looked at supply chain practices in China. And so my question is, how widespread are these practices in China? And also, do you see this happening in other countries to the same organized extent?
Yeah, actually in China, the degree of adoption of digital technology, big data analytics, and also AI really vary a lot. Okay, so when I show you that PPT, I identified these area as a critical area for innovation, but these innovations are really happening like in Haier as a manufacturing example, and then Shunfeng and Jingdong, and we do have these leading logistic companies and also the e-commerce companies. But if you go down further, look at the average company, they are really far, far away from these leading practices adopted by the leading company. As a result, during COVID-19, you see clear divergence in terms of performance. Logistic company, Shunfeng, increased like over 100%. And then some company decreased by 40, 50%. So I think these crises have kind of a wake-up call effect to many companies. But in order for them to catch up, they will have to really change their strategy and try to align their strategic objective with the technology adoption and application, because otherwise they will never really get there. And another model that I see in China is some of the traditional companies, they partner with leading technology company to create a new company with new strategy, new business model. And then they use that as a demonstration case to teach other parts of the organization as to how to proceed in this effort of digitization.
Thank you, Xiande Zhao. And just if you could just extend that argument towards a question that has been raised by Arnaud de Meyer, Professor Arnaud de Meyer from Singapore Management University. He asks, is this concept of regenerative supply chain related to the ecosystem of micro enterprises for which Haier has become known?
Yeah, actually, this is a very good observation. Actually, the reason that they can do the regenerative supply chain, first, they have this micro enterprise and the 人单合一 management principle. And that's really the major management thinking behind it. And then Cosmoplat is a technology platform which really helped to make this happen. And the technology and also the management principle behind it, these two combined really allow Haier to build the ecosystem quickly. But I would like to call this ecosystem as the so-called supply chain plus ecosystem, because the underlying principle behind the value co-creation in the ecosystem actually is supply chain. You see many examples of self-organized, self-drive supply chains, which are really using the resources and capabilities from multiple organizations to meet the needs and wants of another group of organization. And that's how you create the value.
Thank you. Thank you. There's so many interesting questions coming in. I think we have time only for one more, and this probably is directed to Nejhdeh and Lambros. But there are three people. One is Stephen Melnick, Professor Melnick from Michigan State University, and then Christoph Behl, and then Dr. Vic Cortian, who is from engineering at Macquarie University. So let me just summarize all these questions. Stephen asks, how do you sell to upper management? This is for Lambros. How do you sell to upper management data or insights that they don't want to hear? And then Christoph says to Lambros, how do you measure the ROI in data analytics and machine learning? And so Vic then also asks Nej, what have you seen as the ROI for AI and ML projects, and why aren't more companies adopting AI, ML, machine learning type projects? So go for it, Lambros.
Sure. So I think selling to upper management, I kind of covered on before. I think a lot of the time upper management does need to make the end decision, which makes it really cumbersome, because if you don't have the right culture of change from upper management, it's really difficult. I've seen top accounting firms and insurance companies who we've worked with who literally are waiting for upper management to leave so that they can do the things they really want to do. It's terrible how much sometimes upper management can control the direction and can prohibit you from doing the things that you know will push the business forward. As I said, in the case of that bank that I spoke about previously, it worked really well because we started with lower management, built a business case and worked our way up. In terms of ROI, are you happy for me, Norma, to just cut through to that question?
Go ahead.
Cool.
Go ahead.
So ROI of machine learning and AI, and this is probably a good segue also to Nej, but I think in terms of, I think with any project, when you kind of when you're starting to take action, you obviously want to look at the kind of before and after and assess kind of what will happen. I think with machine learning, it's not necessarily going to change. It's not going to, we spoke about prescriptive behavior, which is that fourth step, which is really where machine learning starts to come in, because it uses historical data to propose what you should do, what actions you should take. So the ROI is not necessarily the ROI of machine learning. It's the ROI of the decisions or the actions that you put into practice based on the learnings from those algorithms, from that AI or machine learning. So realistically, what you'd want to quantify is a before and after state. So you'd want to look at, if it's say, if you want to look at say bottom line, or if you want to look at things like DIFOT, for instance, we always looked at when we were working with freight forwarding. It's about, you want to assess kind of, I guess, trajectories over time at a high level. So trajectories year on year, and then assess where things should be in the future based on those standard growth trajectories. And then once you start to implement these actions, look at how they impact that trajectory. So that's one of the kind of primary mechanisms that we would generally use to assess the differential or the ROI. Thank
you. Nej?
Okay. So just, great. I mean, Lambros probably answered all the questions, which is good, right? Okay, that's a tough one. So Vic said, Professor Cortian said, what sort of ROIs are we seeing in the field? Okay, so difficult to answer. So what we see is we work with clients to show that it's not all about, can you decrease customer churn by 5%? Can you reduce cost of the logistics transport by 2%, and so forth? Of course, you have to have a use case. You have to have some sort of a quantifiable, I guess, outcome. But I think what we also like to work with clients is not all about the bottom line, as Lambros said, bottom line ROI. It's also about the actionable insight and the features that can be extracted out of the data that can be extrapolated into the other use cases or other business problems that the organization can face. So, for example, the diagnostics, did you know that your trucks, you have 2 more trucks running on Fridays that you only need 1? Or there's indirect results that you could say it's an ROI, but it wasn't previously planned as part of the use case project to come out and say decrease, cost of the trucks by 5%. So that's the best way I could answer, Vic, in terms of what sort of ROIs we see on the field. It's all about this indirect outcome or as a result of doing proper fundamental data analysis through the whole, right up to the prescriptive and diagnostic analysis.
All right, thank you. I feel we've only scraped the surface on this marvelous journey of restoration and reconfiguration through digital and analytics. There's a lot more for us to learn about digital technology, about big data analytics, AI, predictive analytics, and supply chain ecosystems and collaborations. The how-tos, the challenges, and benefits of adoption. Our experienced and knowledgeable panelists have helped us to talk in these terms and be more comfortable in the world of the digital natives. At this stage, on behalf of Macquarie Business School, I would like to convey our sincere appreciation to our panelists, Nejhdeh Ghevondian, Lambros Photios, and Xiande Zhao, for their superb presentations and discussions in our topic, restoration and reconfiguration through digital and analytics. I'd like to thank my support team, Razia Tavaloy, Alina G, and Carlos Abeja. I certainly value your support through the conduct of these webinars. I'm grateful to our sponsor, the Port of Newcastle, and also thank our supporters, Macquarie Business School, Center for Workforce Futures, Michigan State University Broad College of Business. And finally, I'd like to thank you, the audience, for your feedback and your interesting questions. And my apologies if we couldn't get to all of them, but please write to us with your questions, and if possible, I could redirect them to our panelists. We will release the recording of the session to all those who have registered, and you're free to use it in your lectures, your meetings, illustrations, and discussion points at your workplaces. We hope you remain safe and well, especially in these difficult times around the world. We hope you'll join us again on the 30th of September, Australian, Sydney time, next week, 9 a.m. for the last webinar in this series, and it's called Digitalization, the New Normal for Logistics and Transportation. And in the meantime, we wish you all the best. Thank you.